You okay? Am I good? All right. If I start talking too fast, just raise your hand or something, let me know. If you know when I start presenting. But the title of my presentation is Autonomous Robots. But before I jump into that, I just want to give you a little bit of a background about who I am and how I got into this topic. So, my name is Mark Stratis. I'm from the United States. I came here last week, so this is my first time in India, so I'm pretty excited. We went to Bangalore first for a few days, and we came here, so it's been a great experience. Uh, Within the United States, I'm from Ohio, from Cincinnati. Cincinnati's on the southern end of Ohio, right near the border of Ohio and Kentucky. I went to school at Miami University, which is also in Ohio. Got my degree in computer engineering with minors in computer science and entrepreneurship. And now I'm an iOS developer. So I work for the Kroger company, working on their iOS mobile app. If you aren't familiar with Kroger, Kroger is a grocery store. It's the largest grocery retailer in the United States. As you can see, you can go into the stores. They have meat, dairy, produce, flowers that you can buy. It's a very large store, and they're all over the United States. A lot of times when I tell people I work for Kroger, they just assume that I work inside the store. However, I actually work on the mobile app. I'm working with some of you here today. So this is just a brief overview of what the mobile app is. You can see the home screen here. There are different sale items and products that you might find within the store. You can see weekly ads for what may be on sale this week. You can load coupons to your card. That's all kinds of functionality. But that doesn't relate at all to autonomous robots. So what's my experience with that? While I was in school, I had an internship at Wright-Patterson Air Force Base, which is Air Force Base in Dayton, Ohio. And I was in the Air Force Institute of Technology. So I wasn't actually in the Air Force, but I was doing research with them. They did research on navigation with GPS and without GPS. So how do you navigate in environments when GPS may not be available to you? And I'll get into what that means in a little bit. So first of all, what is an autonomous robot? Autonomous robots are any type of machine that can perform complex tasks without human intervention. So I can press a button and a machine, the robot, will actually go out, perform that task. It knows what the objective is, it knows how to navigate, and it can complete the task, and then when it's done, it can return back to me. However I may program it, or however it decides that it should behave. That's essentially what an autonomous robot is. One of the things that I learned this week is that robots are actually one of the seismic shifts in technology right now. It's a topic, one of the top 5 topics that people are talking about today. And that's something that I heard in India just a couple days ago. So you can have autonomous robots as simple as a Roomba. Has anyone seen a Roomba before? A Roomba is a vacuum cleaner. So say you have a rug and it gets dirty, there's dust on it. Roomba is something that doesn't have too much knowledge, it doesn't use very many sensors to navigate. It just knows that I'm going to start to pick up the dust, I'm going to move forward, and then if I hit something, I'll turn a little bit, move forward again, turn a little bit, and go until I can hopefully reach the entire room. So this is an example of what that may look like. This is a picture of a Roomba that had LEDs attached to it, and it's a long exposure picture that tracks the movement of the Roomba as it moves around the room. So you can see in some areas it didn't really clean anything, a lot of areas it overlapped a lot. So it's a pretty trivial example of an autonomous robot. Another thing that you may have seen on the news recently is driverless cars. So Google, for example, they're working on implementing self-driving cars. And I just read it earlier this week that they're about to start testing with real passengers. So they've had some of the engineers in the car before, and they've walked hundreds of thousands of miles. And they're getting to the point where these cars can read everything in their environment. They can see people as they cross the roads, trees, stoplights. There are lines on the road that in America, people usually stay between the lines. So the car will actually try to stay between the line. That's actually been probably one of the most interesting things to me since I've been here, is just differences in traffic patterns. And that's an interesting problem that driverless cars may have to solve. They can be more efficient, and really, the cars are communicating not only with the sensors that are attached to it, but with the cars around it. They know when they may run into each other, how to navigate to avoid obstacles, and really we can be more efficient. So that's a very large example and a very expensive example. Something that's more mid-range is actually a project that I worked on while I was in school at my university called the Red Blade. And the Red Blade is a robot that's about 3 feet long by 2 feet wide. And it's actually a multifunctional robot in that it can perform 2 different tasks. It can plow snow when it snows in the winter in the United States, and it can also mow grass. Now, mowing grass is a task that a lot of people, they have yards that maybe once every week or two they'll go out and mow it. It's a very manual task. It's something that it's a chore. You don't really want to do it from week to week. You don't. If a robot could take over that task, you get an hour back of your life that you can spend doing what you want. You can spend with your family. You can go out and do something. So if you can have a robot take this manual task away, that's a pretty big deal for you. Plowing snow. Has anyone in here not seen snow before? Or had to drive in the snow? It's a very difficult task. It's in the winter, it can snow many inches at a time. And these snow plows go out, and if they don't plow your road, you really can't drive down it until a snow plow goes by. Because it's very slick, it's very dangerous, and it's not something that we enjoy dealing with. So, Red Blade, you can see an actual picture here, is what we were designing to help solve some of those tasks. And actually, there were many schools that were trying to solve the same problems. So there was actually a competition hosted by the airport to do just that. And they gave us a plot of land that had grass on it. It's an odd shape, has a flower bed in the middle, has a fence along the side. And the goal was to mow the grass in this area, and only the grass in that area, and avoid obstacles along the way. So avoid the flower bed, avoid the fence. And how do you do that? So our robot had many different sensors mounted on top of it. There was a differential GPS, which the GPS unit you may have in your cell phone. It talks to the collects data from the satellites, processes that information in real time, and tells you where you're located. Differential GPS actually uses 2 different positioning systems. One that's stationary, it has a known location, so I'm going to stand right here and not move. I know exactly where I am. And then the robot will move around it. It also has a GPS on it. And by calculating the distance between the two and where they both are, it can actually get very, very accurate. An inertial sensor, that would be more of like an IMU accelerometer, where it tells you as you accelerate in a direction, how fast you're accelerating, which way you're moving, which way relative to where you started. Wheel encoders, those will tell you how far your wheels have rotated. So if I've driven 10 meters, it does these wheel encoders to read the shaft on the wheel and tell me that I've turned exactly 10 meters. A scanning laser can also see obstacles off in the distance. It has a laser, I think this one is 180 degrees, where it just scans back and forth super quick, and it can tell you exactly at what angle in front of you there's an obstacle and how far away it is. Touch sensor. So sometimes we can actually get up to an object similar to a Roomba, touch it, and we know that, okay, we've reached our destination, time to move on to the next. Some of these, for example, the laser may be helpful for if you're driving down the road and you don't want to hit a pedestrian. You don't want to use a touch sensor for that. You don't want to get up and slam right into someone and then know that, okay, I should stop. So how do these all talk to each other? I'll just talk from a pretty high level. You have those various sensors that I just mentioned to you, and then a software suite that kind of uses it all together. So using however many sensors you want, you can get a better reading of not only where you are, but which way you're facing. So position and heading. Um, and that will also control your path plan and some of your complex algorithms for what the autonomous aspect should actually be. How do I control myself? And then, of course, there's the mechanical platform, which will be wheels, the frame, anything just to keep the structure together. In our case, it also included a cutting blades to cut grass, and also a blade up front to push the snow forward and out of the way. And very high level, I'll demonstrate this in the next slide. Essentially, you have waypoints. A waypoint is, okay, here's my starting position. I want to move up to the projector. So the projector is my first waypoint. Second waypoint may be the screen up here. So I know I've reached my second waypoint. As soon as I've reached all my waypoints, which may be static, they may be dynamic, I know that my task is complete. So here's essentially what the robot did. We used our GPS to measure the various corners of the rest of your road, and based on that, we know the shape of the yard that we're mowing. So we can start to form some waypoints. We don't have them all yet, but we're getting there. So the robot can move forward, using its touch sensors to know that it knows that it just ran into a flower bed. And it was kind of cheating a little bit because in this competition we knew that there was going to be a flower bed there. But now it uses, it's trying to go around the flower bed and keep a static distance so that it can at least get right up along the edge. Because you don't want to go around it and have a bunch of grass and weeds. It's a little hard to see, but now I know where the rest of my waypoints are. The robot can start to move around. I'm not going to bore you with going through the entire thing, but the robot will move forward, use its touch sensors to get up to the fence, and then the yellow on top is actually the GPS unit, so it knows that, okay, those yellow points are where I want to go to next. And that's representing the waypoint. So once I finish that, I can start to move around throughout the rest of the land. And they have other obstacles along the way too. So when I was talking about pedestrians earlier, there's this dog off in the distance. The dog may run out in front of me. Well, I don't want to actually hit the dog. So the dog runs out, I can wait for it. Once it moves away, I can continue with my path. While it's moving, what if there's some wind or something knocks it along the way? The IMU knows that it's turned, so it's not facing straight anymore. It's not facing towards its destination. So we'll use the wheels and adjust the wheels accordingly to self-correct itself back to go towards its initial waypoint. And so that's an example of kind of this mid-range, some more research-based stuff that can be used for something like the Google cars, the self-driving cars. Of course, there are other robots that can build those cars. So, of course, these robots are completely building a car from the ground up. It knows how to build it, what parts go where, how to weld it together. And that's all great. But one of the big topics recently have been drones. You see drones all over the news. A drone is any unmanned aerial vehicle, so you may have heard of UAVs. It could be anything from something that fits in the palm of your hand to a plane that's millions of dollars, that costs millions of dollars to build. It can be something that you custom build yourself, so you buy all these parts online, put some propellers on it, have a little computer on top, have a remote control that controls it. And then you can even program some of your, if you have a computer on it, of course, you can program it to do what you want it to do. There are also some commercially available drones. This is actually one that I have. I'll get into it later, but all of the sensors are built right into it. It has a camera on it. But where it starts to get really cool is what all can I do with this? So a lot of times robots can be better at performing manual tasks than humans. Like, for example, this pole right here. If I try to balance it, I can't really balance it. If I can only do this for maybe a couple seconds at a time. So you can see these drones are actually flying and balancing poles and throwing them back and forth between each other. If anyone wants to come up here, I don't think I can balance this and throw it to you and have you catch it and then balance it at the same time. So these robots are doing something that we can do ourselves. So it can be kind of a hobby. This is just kind of a stupid video that I took when I first got my drone. It was my Christmas card that I put on Facebook to send to everybody. So it can be fun flying it around. Some people are racing these. So this is actually something that was on TV, a series of drone races as they flew around various arenas. You can have first-person video, so you can actually see what the drone is seeing as it's flying around. It also has more autonomous functions as well, so not quite as complex as the pole that's being talked about. This is in Cincinnati, actually, so you've never seen Cincinnati. This is one of the residential areas, and we'll begin to see the downtown area. So these are all buildings, the government buildings over here, and the river that goes through the city. And so this video was actually taken. I flew right over the top of the church, looked straight down, and my hands aren't even on the control right now. It's flying around a singular point, so imagine this is the church. This nose to fly around and point the camera directly in the middle. So I'm not touched, nothing is controlling this right now other than the computer on board. So once we get into more commercial uses of this, I'm sure you've heard of Amazon. Amazon has been in the news recently for wanting to test drone delivery. So you buy something, they package it up, attach it to a drone, and then fly it right to where you are, right from there. It can also be used for something like 3D mapping. If I'm in an environment, if I want to just have a drone, it goes out, takes pictures all around the area, it has various sensors to know how far obstacles are, I can actually begin to map environments. Maybe environments that are too dangerous for someone to go to, maybe you're prospecting some land for some new tech areas, some new houses, same thing with statues. So this is actually kind of cool. So there's a statue, obviously, someone went out, mapped it with a drone, and then used a 3D printer to actually print out the exact replica of that statue. And these are all drones that are, it's just a singular drone. I mentioned earlier with the cars, what if the cars were able to talk to each other? Cars can, as they're going down the roads, use their sensors not only for seeing obstacles, but talking to each other as well, and performing a common task. So one example would be these drones that are flying in a swarm. They're just flying, there are like 16 of them, trying to fly through this hole, which may be a window. You could send a bunch of drones into a burning building, for example, have them go from room to room looking for people to see if there's anyone who needs help. And they can talk to each other to know when they go through the entire building so that they know, okay, the coast is clear, no one's in there, we don't need to send any firefighters in to risk their lives because we know that no one else is in there. So some other commercial uses may be media, for any type of video that you want to film, you're filming a sporting event, cricket, football, anything, tree planting. So if I want to reforest an area, I can actually put some sensors on there, some various motors to actually go out. If I want to plant trees every 10 meters from each other, I can start to drop and plant trees without any human interaction whatsoever. I can take pictures of houses, various areas, do some prospecting, get medical supplies from remote areas. So say traffic is too bad or something is too far away and someone is in urgent need of medical supplies, I can actually take the drone, fly it to them with medical supplies while someone is on the way to be able to help. The medical supplies can get there ahead of time so that there need to be bandages or anything to help them out. They get a head start. Can also be used for military. So warfare, disaster relief, similar to what I was mentioning, but fire recovery, sending the swarm drones, any type of surveillance. This is actually some idea. You guys see that? Might not be working out too well. I'll try to narrate. Alright. So we're building our robots that are drones, but they actually look like things. So make so a robot can potentially be flying around taking video and not even be detected by anyone in the area. So you can send it into a building. You potentially look like a bird perched up on wire. And one of the limitations of drones actually is battery power. So people are actually doing research into how you can take a drone, have it land on a power line, and actually harness power from that and recharge its own batteries. So you could have something with a camera. It's kind of scary actually. It's invasion of privacy. But these are some of the things that people are looking into. This is a wing to actually make it look like it's an insect that's flying. So you can use to be able to fly like a bird or a butterfly up and down and actually have the same look and feel on the insect. Alright, so some of the limitations, like I mentioned, battery life, invasion of privacy, safety, if you find someone and one of the propellers flies off, it hits someone in the face and cut them open. There are also some laws and regulations. I'm not sure what the laws and regulations are in this area, but there's just something to keep in mind. Now, if you're custom building your own drone, you can also rate your own software. There are some open source toolkits out there where you can go in and they have ways for the various computers to talk directly to the sensors, so directly to the propellers that make it fly, some of the sensors for knowing which way it's facing, GPS and whatnot. And you can also potentially even take commercially sold drone and hack it yourself, try to figure out and do some reverse engineering. So one of the things that I told you at the beginning, I work for Kroger. What does that have to do with drones? Well, I don't really know, but in the future, imagine that I'm walking around the store. I could just have a shopping cart that's out in front of me with an arm, pulling things. I create a shopping list, pull things off the shelf for me, and put it in my cart. It could also restock shelves for me, maybe load trucks so that it takes some manual aspects out of it. Um, the self-driving cars. I'm going to deliver to someone. Maybe I pick the groceries myself, bag them up, put them in the car, and that car on its own knows where to drive to the customer who ordered those groceries. Even drone delivery, similar to what Amazon was talking about. Of course, we're not researching any of these right now, but these are some possibilities that maybe down the road we may see. I'm not sure if anyone else has any ideas, but of course I'm open to hearing from after. So really, that's all I have about drones. I didn't get too into the weeds with it, but if anyone has any questions, I'll be around the rest of this week and next week in this office. So you come up and talk to me, I'd love to talk to you. I'll leave you with one other video that I took as I take any questions if anyone has them. So this is another view of Cincinnati. So on Labor Day, the American Labor Day, I think you guys have a holiday coming up on Monday. They shoot fireworks off the river in Cincinnati. So this is another example of when I took the drone and pre-programmed the routing to it. So I'm not even touching anything right now. The drone's just flying on its own, and I programmed it to look toward the city and it's capturing some fireworks as it flies down the river. Does anyone have any questions? This is a curve going right now. So you can see how these drones may be used for some for filming some videos, for movies. A pretty good camera. And I say this is just a mid-range drone that I just purchased off of Amazon. Thank you. So the battery life of a drone like this is about 20 to 25 minutes. So that's pretty limiting actually. You can't really set it out over a great distance. So someone like Amazon, they may have some other options. So I think one of the proposals was that the drone may take off using battery power, and then as it's flying forward, use some other type of fuel to go over long distances and use batteries for the propellers just to go more up and down motion rather than the horizontal over long distances. Correct. I should have taken a screenshot of it. I wish I would have. But it would just be something similar to this, where really I just put in different points on that. And there was a third-party app out there available to me. I made it really easy. Put in points on the map. And in addition to this, which is just more of a two-dimensional area, you can put in altitude as well. Altitude with GPS is a little less accurate than the latitude and longitude, but it gets you pretty close to accurate.
Another question. So what, like you flew it in city space, right? So what are the regulations in US on this? Flying drones in city space, or as
Well, so that's one of the things that I have here is you're actually supposed to register your drone with the FAA, which they kind of manage all of those guidelines in the United States. 400-foot altitude, so it's supposed to stay below 400 feet to stay out of the local airspace. I'm always supposed to see it as I fly. Never supposed to lose sight of it without any help with binoculars or anything. Um, Away from airports, away from people. Um, a lot of cities have no-fly zones around them, so the FAA actually has a website where you can go and look up your area and see where it's safe to fly and what the regulations are for your area. I'm not sure what the equivalent is, but they make that information pretty easily available. And also, there are some regulations if you want to make money with the drones. So if I want to take video and sell it, I have to get a special permit to be able to sell my work. I don't have it. It's fairly complex, but there's more information out there for it's called the Section 333 exemption. But you go through a lot of research and you have to take a test. And once you pass the test, then you can actually go out and start to do whatever you want commercially. Anything else? Thank you.